A circle centered at the origin with a radius of 1 is called the unit circle, and its equation looks something like this. In a previous video, we've shown how every point on the circle, this unit circle, gives us the values of cosine and sine for the corresponding angle theta, where the x-coordinate represents cosine of theta and the y-coordinate represents sine of theta. Therefore, we could rewrite this equation like this. So cosine of 60 degrees, cosine of 135 degrees, cosine of 240 degrees, and cosine of 300 degrees are all 0.5 minus 0.71 minus 0.5 and 0.5 respectively. Remember, the numbers may be given in decimal form, or they may be of some fractional equivalence. Your calculator will most likely give you a decimal answer, while the answers on your test or solutions your professor may provide will have a fractional form, such as square root of 2 over 2, square root of 3 over 2, or simply 1 over 2. Similarly, sine of 60 degrees, 135 degrees, 240 degrees, and 300 degrees are all 0.87, 0.71, minus 0.87, and minus 0.87, respectively. So now you can see how cosine is related to the x-coordinate of these points, and sine is related to the y-coordinate of these points. Whether we use degrees or radians, the values of cosine and sine are still related to the x and y coordinates of these points. We can even use negative angle measures. Here we have negative 45 degrees and negative 150 degrees. And still, cosine of minus 150 degrees is minus 0.87, and sine of minus 150 degrees is minus 0.5. But how do we use the unit circle for angles that exceed 360 degrees or 2 pi radians? For example, how do we evaluate cosine of 495 degrees or sine of 9 pi over 4? Well, this is where coterminal angles really come in handy. If you have not watched my video on coterminal angles, now's a good point to stop and go watch it. You'll need it for this next part. Notice how 495 degrees is 135 degrees plus one rotation of 360 degrees. So 495 degrees is 360 plus 135. Therefore, we know that 495 degrees is coterminal with 135 degrees. So what is cosine of 495 degrees? Well, it's the x-coordinate of 135 degrees, since they're coterminal. So cosine of 495 degrees is equal to minus 0.71. In the same way, 9 pi over 4 is 2 pi plus pi over 4. Therefore, 9 pi over 4 is pi over 4 with one extra rotation. So what am I saying? I'm saying that 9 pi over 4 is coterminal with pi over 4, or 45 degrees. So then to evaluate sine of 9 pi over 4 is the same as evaluating sine of 45 degrees. So therefore, our answer would be 0.71. This is the breakdown of what we just showed. 495 degrees is 135 degrees plus an extra revolution of 360 degrees, which implies that 495 degrees is coterminal with 135 degrees. So instead of determining what the cosine of 495 degrees is, simply find out what cosine of 135 degrees is, which we showed was minus 0.71, or minus square root of 2 over 2. And in the same way, we show that sine of 9 pi over 4 is equal to sine of 2 pi plus pi over 4. So therefore, sine of 9 pi over 4 is equal to sine pi over 4. And we can evaluate that to being 0.71, or square root of 2 over 2. If this was a little confusing towards the end, it's probably because we haven't worked on our coterminal angles enough. So I encourage you to go back and refresh your memory on those.